What they sell today as artificial intelligence, ChatGPT, Grok, Gemini, and the rest, is just an algorithm called the transformer. So how does it work? And how does it manage to pass for a human in a conversation, sometimes more convincingly than actual humans do? Now we're going to take your brain's right hemisphere, the one commonly associated with creativity and emotion, and your left hemisphere, the one associated with logic. And with those, we'll tightly grasp the transformer from both sides and carry it over to you, the viewer. Try not to drop the essence of transformers on the way. A transformer generates text, one word at a time. Every new word is born in 4 stages. So we divided our story into 4 parts and called them acts, like in a play. Each act consists of 2 halves, an artistic one and a mathematical one. The former helps you remember what is happening, and the latter helps you understand it. The first, artistic half of each act is a psychedelic story about caterpillars and butterflies. Before uploading this video to YouTube, we showed it to our friends. They told us it was too violent and disturbing. Disturbing enough that YouTube might ban it. But it is not shock for shock's sake. It's a memory technique. As Cicero said, if you want to remember something big and complicated, say a speech before the Roman Senate or the transformer algorithm, you should imagine the most vivid, the most indecent, and the most shocking images possible. So in this video, we did our best to make the transformers' inner workings burn themselves deep into your memory. But let us be clear, this body horror is purely educational. We absolutely do not enjoy any of this. The second half of each act is a mathematical explanation of what is what in the story. We are not trying to present a fully rigorous, exhaustive explanation of the transformer algorithm, but rather to expose the mathematical skeleton underneath. The entire impressive behavior of a chatbot boils down to one simple trick. The transformer computes the next word. For example, we fitted this phrase: the quick brown fox jumps over the lazy, and the transformer computes the next word, dog. This video is a detailed breakdown of where the dog comes from. These little houses along the river are the village of Transformerville. Inside each house lives a caterpillar. A mating season begins. At the end of each mating season, a brand new house appears by the river, and with it, a brand new caterpillar. The village can grow along the river forever. That new house on the far right is the last house in the village. Let's peek inside and see what mating season looks like in Transformerville.
Hi, I'm Takinyasha and I live in this house. Today you are about to witness the most intimate moments of my life.
A mating season lasts exactly 100 days. And each day in Transformerville follows the exact same sequence of pagan festivities and bloody rituals. Takinyasha opens a cabinet. Inside are 100 drawers, one for each day of the mating season.
Every caterpillar in Transformerville has a cabinet like this. And all our cabinets are exactly the same. Identical in every detail. Same drawers, same contents, same everything. So there is nothing to be jealous of. Every drawer has 4 compartments, and each drawer contains the same set of tools in the respective compartments. In the first compartment, 5 sets of elegant syringes. In the second one, nothing. In the third one heavy, beautiful syringe. And finally, in the fourth one, 2 luxurious rubber bulbs. Inside the syringes and bulbs are special substances used for transformation, matrix essences. The essences in different drawers are different. There are no 2 identical essences anywhere in the cabinet.
We've got Takinyasha on the first day of the new mating season, so she opens the very first drawer. Each drawer in this cabinet has 4 compartments. Each compartment corresponds to one act of our story. 4 compartments, 4 acts. Inside the first compartment are 5 brightly colored boxes. One for each of Takinyasha's 5 daughters. But what are those gifts, and what are the daughters? Every caterpillar in Transformerville not just Tokinyasha, has exactly 5 daughters. They all have the same names: red, orange, yellow, green, and blue. So there is the red daughter of the first house, the red daughter of the second house, and so on. In other villages, there might be more or fewer daughters, but in Transformerville, every caterpillar has exactly 5. Tokinyasha doesn't have any daughters yet. She is about to make them. She creates all her daughters in the same way. Let's see how she creates, say, her red daughter. First, using a cloning machine, Tokinyasha creates 3 identical clones of herself. Then she takes 3 syringes out of the gift box for the red daughter. The first syringe is called How Do I Appear? The second is called Whom Am I Looking For? And the third is called Who Am I? Tokinyasha injects 1 syringe into each clone. This causes the clones to pupate. Then each chrysalis opens. From the chrysalis injected with How Do I Appear? A pair of red wings emerges. From the chrysalis injected with Whom Am I Looking For? A pair of red eyes emerges. And from the chrysalis injected with Who Am I? There hatches a red butterfly body. No eyes, no wings, just the body.
Look, these are the eyes, wings, and the body of my red daughter. Now, I put them together, and there she is, my red daughter. Every day I get a new red daughter. I love them all.
After that, in the exact same way, Tokinyasha creates the other 4 daughters: orange, yellow, green, and blue. The daughters are born quickly. It is still morning, and they have a busy day ahead of them. All the daughters of all the caterpillars of Transformerville leave their houses to celebrate their birth and meet one another. And that is the end of the first phase of the first act. We move on to the second phase, the left hemispheres part, the explanation of what exactly have you just witnessed. Indeed, how does this psychedelic story help us understand the Transformer, you may ask? Every caterpillar is a word. The row of houses along the river is a sequence of words in a sentence. The emergence of a new resident in Transformerville is the generation of a new word. One mating season yields 1 new caterpillar. The season consists of 100 days. In our analogy, 1 day of the mating season corresponds to one of the Transformer's 100 blocks. And the entire mating season, along with the emergence of the new caterpillar in the new house, is the process of generating 1 new word. In a Transformer, each word is represented as a list of numbers. The values matter and their order matters. We call this list a token. We'll also use another word, vector. A vector is simply the mathematical term for a list of numbers. Every token is a vector, though not every vector inside a transformer is a token. As the transformer runs, tokens interact with one another and change. The next word is determined by the last token in the last block. In our story, the caterpillar in the last house on day 100. In essence, a transformer is just a long sequence of matrix multiplications and additions. The caterpillars and butterflies are there to help us remember how those operations are organized. A token has a fixed length. For a medium-sized model, imagine something like 500 numbers. The word fox is 500 numbers. The word jumps is another 500 numbers, and so on. The meaning of the word is encoded in those 500 numbers. An injection transforms the caterpillar. So what does the injection represent? To transform a token, we apply a matrix to it. A matrix is just a table of numbers. Those are the essences stored in the cabinet. A matrix is injected into the token, which causes it to change. In the formal language of linear algebra, it is called multiplying a vector by a matrix, since a token is a vector. A vector can only be multiplied by a matrix if the matrix's height matches the vector's length. A square matrix leaves the vector length unchanged. A rectangular matrix can make it longer or shorter. Multiply a length 3 vector by a 3x4 matrix and you'll get a length 4 vector. Multiply it by 3x5 matrix and you'll get a length 5 vector. Multiply it by a 3x2 matrix and it shrinks down to length 2. All 3 matrix preparations are different, but are of the same height and length. So the syringes are the same, but their contents are different. The hatched wings, eyes, and the body are 3 new vectors of the same length, obtained from Tokonyasha's clone, using 3 different matrices. Typically, these matrices are chosen so that the resulting vectors are 8 times shorter than the original token. These new vectors are called K, the key, or how do I appear? Q, the query, or whom am I looking for? And V, the value, or who am I? Those are the exact same letters you saw on the syringes. The red dot is the 3 vectors produced by multiplying Tokonyasha's clones by 3 different matrices. The daughters of the other colors are formed the same way, but with different matrices. And that brings us to Act 2. Let's follow these 3 vector daughters further. All the butterfly daughters of all the caterpillars leave their homes and meet in social clubs. The villagers call these clubs attention heads, because they look like heads and because the butterflies are going to be paying very close attention to one another inside. All the green daughters gather in the green head. All the red daughters gather in the red head. And so on. Each butterfly only enters the club of its own color.
They invited me to the green club. I refused, obviously. I'm red, and I only party with reds.
There are exactly 5 clubs in Transformerville. In other villages, there may be more or fewer, depending on how many daughters the caterpillars have. So, what happens inside these clubs? The same thing in every one of them. Let's have a look at what happens in the red club. The others work the same way. Only the red daughters have gathered at the red club. Butterflies of other colors are not allowed in. There is 1 red daughter from each house. The party lasts exactly 1 hour. During that hour, the butterflies look at one another and evaluate one another's wings using their eyes. Every pair of eyes is unique, just as every pair of wings is unique. And from the perspective of different eyes, different wings are attractive in different ways, just like in real life.
The most interesting thing about a butterfly is her wings. I look only at wings. Everything else, frankly, does nothing for me.
The more a butterfly likes another butterfly's wings, the longer she looks at them. At some, she looks for dozens of minutes out of the hour allotted to the dance. At others, she barely glances.
And yes, I evaluate my own wings too, so do all my friends. There is nothing wrong with healthy self-regard.
Right now, there are 13 houses in Transformerville, so there are 13 red sisters in the red club. And we can see 13 slices on the clock corresponding to the attention each butterfly gives to all the others, including herself. So each butterfly ends up with her own personal map of preferences. When the allotted hour of dancing ends, the transformation begins. Each butterfly sheds her eyes and wings because she doesn't need them anymore. She has already judged everyone, including herself. The butterflies burn their wings in a great bonfire. The eyes go into the fire too. The eyes were only ever needed to look at wings. Then a synchronized mass mutation begins. Each butterfly becomes proportionally similar to the butterflies whose wings she spent the most time looking at. The red daughter of Tokinashi spent an especially long time looking at the wings of the daughter of Van Tokensberg, who has these wavy black legs. Tokinashi's red daughter's own legs lengthened and darkened, like the legs of the butterfly she looked at so long. That is how all daughters of one color exchange their traits. Each butterfly mutates in accordance with her preferences. And this happens simultaneously in all 5 clubs.
I left that club with no eyes and no wings, and I'm still ecstatic. It was a great day and a great party. My eyes stayed there. I can't see the bonfire of our wings, but I can feel its warmth. Attention heads rule.
And so the butterflies leave their clubs, satisfied and mutated. What happens next? We'll see in the third act, but first, let's sort out what exactly is hiding behind the clubs, the eyes, the wings, and the mutations. If you've ever been to clubs like this, hit the like button. What lies behind the butterfly's party? Words in the text are related to one another to different degrees. In other words, some wings appeal to some eyes more than others. You can think of it like this. Some words in a sentence pay more or less attention to other words. For example, in the sentence, "The quick brown fox jumps," the word brown is strongly connected to fox, but much less strongly connected to jumps. And those connections determine the daughter's behavior in the club. Both the eyes and the wings of the butterflies are vectors. But how can one vector look at another? How do we express mutual attraction? In mathematics, we use the dot product. For 2 vectors of the same length, and that part is important, it produces a single number. This is an example of how it is computed. Take the first numbers of both vectors and multiply them. Then we do the same with the second pair. And then with the third. The sum of all those products is the dot product. In this example, we get -9. The dot product can be positive as well as negative. Whenever eyes look at wings, the transformer computes the dot product of Q, the eyes, and K, the wings. A positive number means the eyes like the wings. Small numbers near 0 mean indifference. A negative number means the wings seem repulsive to those eyes. By the end of the party, each butterfly has a list of scores for all the other butterflies in her club, including herself. Because each butterfly only visits the club of her own color, a red butterfly only scores the other red butterflies. We won't need the vectors Q and K anymore. What remains is vector V. The vector V is the butterfly's body, and it is the body that mutates at midnight. How does that mutation work? There are 2 steps in this process. Step 1 is transforming the list of scores. That list usually contains both positive and negative numbers, because every score is a dot product. But we do not want raw scores, we want fractions. How much to take from the first one, say 34%, how much to take from the second, 14%, and so on. To transform a list of scores into a list of fractions, the transformer uses a procedure that specialists call softmax. You can learn more about softmax by clicking the link on the screen or in the description. Step 2 is the mutation itself. We write down the fractions and according to those fractions, take the butterfly's bodies. When we combine the results, we get the desired body. Each body is a vector, and taking a fraction means multiplying the vector by its percentage. To multiply a vector by a percentage, we multiply each of its components by that percentage. By adding those fractions together, we obtain the final mutated vector. This final vector is extremely important. It has absorbed whatever information was useful from all the other bodies, the other V vectors in the club. Such vector is produced for every word. That means each word has 5 mutated butterflies of different colors. Every word interacts with all the others on 5 differently colored levels. The process of exchanging traits on each of these levels is called the head of attention. Each club is one such head. In our example, there are 5 heads, red, orange, and so on. But in Llama 4, for example, a large modern language model, there are 40 heads, as many as 40 butterfly clubs. There are many different kinds of relations between words. For example, words may pay attention to one another's grammatical gender, or grammatical tense, or whether they belong to the same fixed expression. Different heads are responsible for different kinds of such links. The attention mechanism is the beating heart of the transformer. It is what makes it work so well. And thus concludes the second act. You have already made it halfway through. It is the hardest part, by the way. Now on to the third act. So, the butterflies have already met one another, burned their eyes and wings in a beautiful pagan ritual, and finally mutated. Lit by the flickers of the burning wings, the transformed daughters leave the clubs and head home. All 5 of Tokinyasha's daughters have returned from the clubs: red, orange, yellow, green, and blue.
My new wavy legs are gorgeous. I can't stop touching them. They turned out so well.
Then comes the family evening. Tokinyasha takes a needle and hastily stitches her 5 eyeless, wingless daughters together. And out comes a multicolored butterfly centipede.
Please don't judge. This is a perfectly ordinary family evening in Transformerville. We have our own vibe and our own distinctive culture.
Then she takes the syringe from the 3rd compartment of the drawer and injects the centipede with its contents. The centipede pupates. Inside the cocoon, all the cells are mixed together, and then, out of the centipede cocoon, comes a caterpillar, very much like Tokinyasha. Same general size, same overall structure, but not identical. This is Tokinyasha's first spouse. She resembles her, but she is different. She carries traits from the other caterpillars in the village. They look each other in the eye, and then they merge into a single caterpillar. That is how the updated Tokinyasha is born. Tell us in the comments how Tokinyasha justifies the necessity of all these astonishing transformations to herself. This is the end of the first phase of the 3rd act of our drama. Tokinyasha has transformed her daughters into her spouse and merged with her. So what is behind these events once we switch to the level of computation? What use analogy is used to explain what is in essence a rather simple thing? So what have we got? We have Tokinyasha's 5 mutated daughters, and now she wants to absorb all the information her daughters gathered during their many dates. The daughters can be considered intermediaries for transmitting meaning. Before absorbing the daughters, they must be brought into a digestible form. How, you may ask? By performing concatenation on their bodies. This means nothing more than just gluing short vectors into one long one. But the way it sounds, the ritual of concatenation, the resulting vector is patchy and uneven. To fix that, we use the same approach we used to obtain the vectors q, k, and v, multiplying the vector by a matrix. That is, in caterpillar language, another injection of matrix essence. The result of that manipulation is the first spouse carrying within herself information from the other caterpillars, that is, from the other words. Tokinyasha merges with the first spouse. What does that mean? We simply add the corresponding numbers to the 2 vectors together. And now, the updated Tokinyasha is ready for the next act. So what is the very first thing the updated Tokinyasha does after merging with her spouse? What would you do in her place? Probably call the police and social services? Tell us in the comments. But Tokinyasha is not like that. Tokinyasha wants more. First, she clones herself again. But this time, she sends her clone into a blender. Then she opens the drawer, takes the first bulb from the fourth section, and pours the matrix essence into the blender. From the resultant slurry, she molds a very long caterpillar. She injects it with the substance from the second bulb in that fourth section, and creates her second spouse. And naturally, she merges with this new caterpillar as well. What comes out in the end is once again Tokinyasha. But now it's Tokinyasha at the end of the first day of the mating season. Twice updated, Tokinyasha goes to sleep, so that tomorrow it can all happen again. Ahead of her lie 99 repetitions of the cycle, cloning, pumping daughters full of matrix essences, club meetings, burning wings, stitching daughters together, incestuous mergers with the spouses, and grinding her own clones into the blender. This monotonous day will differ only in the numbers of the drawers, from which she takes the matrix essences. The 100th day is special for Tokinyasha. At the end of that day, after all the usual transformations, she clones her updated self one more time. Tokinyasha's clone builds the next house and becomes the new resident. Tokinyasha is now the second to last resident. At this point, of course, you may wonder, what happens on the last day to the clones of all the other caterpillars? Tokinyasha's last clone became the new resident. But what do all the other villagers do with theirs? The answer is simple: nothing. Their clones on the 100th day of the mating season do not affect the emergence of the new resident in any way. Caterpillar van Tokensberg will now explain it in more detail.
My name is Van Tokensberg. Tokinyasha's house is the next to mine. On the last day of the mating season, I send my daughters to the clubs, as usual. And then I create my clone. But that is merely a tribute to the tradition. At the end of the day, I send this clone into the bioreactor and it disappears without affecting anything at all. Only the clone born in the very last house becomes the new resident of the village. We dispose of all the others. That's just another feature of our distinctive culture.
After the new resident moves in, Tokinyasha returns to her original state, the way she was on the very first day. All the other caterpillars return to their original state too, to the state they were on the first day of the mating season, before all the mutations and transformations. The village is the same as before, with the same residents, except for the one new resident. The mutations and transformations throughout the breeding season existed only for the sake of that one new resident. And the moment she appears, everyone goes back to how they were. And now the village, which has one more resident than before, awaits new mating season. Tokinyasha's house is no longer the last one in the row, but the second to last. Thus the cycle of life closes. And that is how Transformer understands that after the quick brown fox jumps over the lazy, comes the word dog. Now let's translate that into actual computation. First, we copy Tokinyasha, and for now, we will work with the copy. The clone is to undergo a series of operations aimed at making the components of the vector interact with one another. Metaphorically speaking, different parts of Tokinyasha must interact with each other. The attention mechanism has already loaded Tokinyasha with all the necessary information. Now she only has to digest it internally, in isolation from the other caterpillars. To do that, Tokinyasha's copy is sent into what is called a Perceptron, the simplest neural network consisting of two layers. In our analogy, the blender is the first layer of the Perceptron. After all, where else should all of Tokinyasha's parts meet, if not in a blender? And the injection of matrix essence using the bulb is the second layer. Together, those two steps form the two-layer Perceptron. talk about the first layer. We take the Token-Yasha vector, multiply it by a wide matrix. A matrix like that increases vector length, and then we get a long vector as the output. At the input of the first layer, there is a short green vector. The purple vector is the pre-final result of the first layer. In a moment, we will apply a nonlinear transformation to it. Between those two vectors is the matrix preparation by which the input green vector is multiplied. The height of the matrix matches the length of the green input vector. Everything is legal. The next step is a nonlinear transformation. This is the final step of the first layer. Such a transformation is applied separately to each number. For example, let's look at the first three components of the vector. The rest work in the same way. Nonlinear transformations come in different kinds. The nonlinearity, essentially, is that the graph of the transformation is not a straight line. In the simplest case, that is, ReLU, it is a line bent at 0. We transform the number 0.2. We mark 0.2 on the horizontal axis. Draw a perpendicular to the graph. Then move across to the vertical axis. We get the same number, 0.2. And that number goes into the output vector. Now let's take the second number. It is a negative 0.1. Performing the same construction, though it is a bit harder to see because it merges with the graph, we get 0. In fact, any negative number will become 0. We write that 0 into the output vector. Next comes 0.5. It is positive, so it enters the output vector unchanged. The multiplication by a matrix, together with its nonlinear transformation, forms the first layer of the perceptron. We are done with the first layer and move on to the second one. The second layer reduces the caterpillar's length so it can become Token-Yasha's second spouse. The second layer consists of exactly one operation, and that operation is, who could have guessed, multiplying a vector by a matrix. But now the matrix has a different shape. Here, the long input vector that came out of nonlinear transformation is multiplied by a tall matrix. The result is a short output vector, exactly the size of Token-Yasha. Unlike the first layer, there is no nonlinear transformation here. Now we have the second spouse. You may have noticed that Token-Yasha uses bulbs instead of syringes. This is no accident. The model's vast knowledge about the world is stored in these bulbs. How many legs a cow has, or what is the difference between old-style and new-style classes in Python is. Every number in every matrix we have encountered so far is a parameter, also called a weight. And 2/3 of all parameters are in the bulbs. Briefly, once again, here is how the second spouse is created. Step 1. Token-Yasha creates her copy. Step 2. The copy passes through a two-layer perceptron. The first layer, something like a bell, expands the vector and sends it through a nonlinear transformation. The second layer, like a funnel, brings it back to its original size. As the vector passes through the layers of the perceptron, it absorbs knowledge from the bulb matrices. And finally, step 3. The second spouse merges with Token-Yasha, or in mathematical terms, the Token-Yasha vector and the spouse vector are simply added together, exactly as it was with the first spouse. Hooray! We have reached the end of the first day. And there are still 99 more days, 99 more transformer blocks ahead. Inside each block, everything you have seen across all 4 acts repeats exactly, but the matrices used are different. 1, 2, 3. And thus, all the tokens are transformed 99 more times, in the next 99 blocks. The last token in our case, becomes the token of the new word. And that word is dog. We do not use other tokens. They do not affect the final result, though they are needed during the training. In this video, we deliberately do not touch on the subject of training. That is where all the matrix essences come from in the first place. That is a separate, large story, and one day we will definitely tell it. That story will be called Gradient Descent into Madness. Subscribe to the channel so you don't miss it. But for now, all you need to know is that the Transformers knowledge is stored in the cabinet, and that knowledge does not change while the text is being generated. And that is how the Transformer works. This mnemonic story should help you remember the most important thing, the attention mechanism. All those colorful heads, that's this mechanism. The butterflies parting in the head clubs is the beating heart of this algorithm. We deliberately left out many important things. For example, softmax, or the distinction between log probes and tokens from the vocabulary. And we did not mention gradient descent at all. I mean, where do all those magical potions from the cabinet come from? From there, from gradient descent. Perhaps we forgot something else too. Tell us in the comments which crucial parts of the Transformer we criminally overlooked. We tried to keep only the essentials, the broad outlines. It's a mosaic, but the one not yet fully assembled. The missing gaps are easy to fill now, because it is clear where the new pieces belong. In the future videos, we will explain how positional encoding works inside a Transformer. If you enjoyed this video, like and subscribe. It really matters to us. We are a non-commercial project with no ads and no monetization. So the channel depends on your likes and subscriptions, and without them, it will wither away. See you soon!
And remember, friends, this is a completely fictional story. Any resemblance is entirely coincidental.